Topic 3, Patterns, Chapter 4, 3.1 Factors and Primes. A factor is a number that divides evenly into another one. So every number, except for 1, has at least 2 factors. It will have itself and 1. So 1 has only got 1 factor. The factors of 12, so any number that divides into 12, we've got 1 and 12, 2 and 6, and 3 and 4. So the way to think about factors are that they are numbers that multiply together to form the original number. So if we were thinking about the number 24, the factors would be 1 and 24, because 1 and 24 multiply up to 24. You'd have 2 and 12, 3 and 8, and 4 and 6. So there are 8 different factors of 24. So what we do, we start with 1 and the number. We then move on to 2 and see if it divides in evenly, and we write down the other corresponding factor. Move on to 3 and so on until we list them all. And what we'll notice is that the numbers are getting closer and closer together. And once they meet, or once you start repeating numbers, then that's when you would stop. So example 1b, list the factors of 21. So 21, we've got 1 and 21. 2 doesn't go, so 2 and 10 and a half, but we need the factors to be whole numbers, so 2 doesn't go. 3 and 7, so 3 sevens are 21. 4 doesn't divide evenly, nor does 5, nor does 6, and then we're back to 7. So the factors of 21 would be 1, 3, 7, and 21. Now, back in primary school, whenever you were told what a prime number is, we would have focused on this second half of the definition, so a number that can be divided by itself and 1. But actually, that gives us a dilemma with 1, because 1 can be divided by itself, which is 1, and it's also divided by 1. So using that definition, 1 would be a prime number. However, it's accepted in the mathematical community that 1 is not a prime number. So the actual definition is a number with exactly 2 factors. So it can't have any more, it can't have any less, it must have only 2 factors. 2 then is the lowest prime number, and in fact it's the only even prime number. The sieve of Eratosthenes is one way of working out what the prime numbers are. So what we do, you cross out number 1 because it's not prime. So let's do that. Then leave 2 as it is prime, but we cross out all the multiples of 2. So we cross out 4, 6, 8, 10, up until 100. So what we're doing is we're getting rid of all the multiples of 2, and that way we will remove all numbers that aren't prime. The next number we come to is 3, so we're going to leave it as it is a prime number, and then we'll score off all the multiples of 3. So 6 has already been done for us. Then we've got 9, 12 has been done, and then 15, 18 has been done, 21 hasn't, and then we'll go all the way up to 99. So that's all the multiples of 3 scored off. Then go to 5 and do all the multiples of 5. So 10 has been done for us already, so it's 15 and 20. So we've got 25, 30, 35, 40, 45, 50, 55, 60 has been done, 65, 70 has been done, 75, 80, 85 has been done, 95 and 100. The next number we come to is 7, so it must be prime, so we cross out all the multiples of 7. So 7, 14, 21, 28, 35, 42, 49, so it's the first one that hasn't already been scored off. 56, 63, 70, 77, there's another one. 84, 91 and another, and that's them. So 98 has already been done. So all the numbers now that remain are the prime numbers less than 100. So we're going to highlight those, and then these will be all the prime numbers. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So those are all the primes that are less than 100.